Dear learners, welcome to this video on 5 why technique used to define the problem clearly. The 5 why analysis is a problem solving technique that aims to uncover the root cause of a defect or a problem by repeatedly asking the question why. This method, developed by Sakichi Toyota and used within the Toyota production system, helps the teams to move beyond the symptoms to identify the underlying causes of an issue. The 5 whys techniques involves the following steps. Identify the problem. Clearly state the problem or the defect to be analyzed. Ask why the problem occurs and write down the answers. Repeat the process. Continue asking why for each subsequent answers until the root cause is identified. This usually involves 5 iterations, but more or fewer may be required. Identify the corrective actions. Once a root cause is identified, determine the appropriate actions to prevent the recurrence. Implement and monitor. Implement the corrective actions and monitor the effectiveness. Let us discuss a case study on production line downtime. One of the problems in a production line in an industry may be frequent downtime on a production line due to machine failures. This can be caused by several factors, including lack of regular maintenance, wear and tear of parts, and improper handling by the operators. Additionally, using the substandard materials or components can lead to unexpected breakdowns. Environmental factors such as dust and temperature fluctuations can also contribute to the failure of the machinery. This can cause delays in the production and reduce the overall efficiency of the production line. It can also result into lower profits for the company. Let us continue our 5 why analysis on a machine failure. Why did the machine stop? The machine stopped because it is overheated. Why did the machine overheat? The machine overheated because the coolant system is failed. Why did the coolant system fail? The coolant system failed because the pump was not functioning. Why was the pump not functioning? The pump was not functioning because it was clogged with the debris. Why was the pump clogged with the debris? The pump was clogged with the debris because the filter was not regularly cleaned. So the root cause of the production line downtime was the failure to regularly clean the filter in the coolant system. The corrective actions may be taken to implement a regular maintenance schedule for cleaning the coolant system filter. Train the maintenance personnel on the importance of the filter cleaning. Monitor the effectiveness of the maintenance schedule and adjust as necessary. The benefits of this technique is simplicity. It is straightforward and easy to understand. It drives the investigation deeper to uncover the underlying causes rather than just symptoms. It requires minimal resources and can be conducted without an extensive training. It encourages the collaboration and diverse perspectives in the problem solving. Let us consider another case study in improving the lab safety in an engineering education setting context. Consider a mechanical engineering department in an university. A series of minor accidents occurred during the laboratory sessions involving the use of CNC, that is, computer controlled numerical machines. These accidents, although not severe, raised concerns about the students' safety and the need for more robust safety protocol. The department decided to conduct a 5 why analysis to identify the root cause of these accidents and implement an effective solution. Students have experienced minor injuries while operating CNC machines during the lab sessions. In the first why did the students get injured? The students got injured because they were not following the safety procedure correctly. In the second why were the students not following the safety procedures correctly? The students did not fully understand the safety procedures. In the third why did the students not fully understand the safety procedures? The safety training provided at the beginning of the semester was insufficient and rushed. In the fourth why was the safety training is insufficient and rushed? The lab schedule was packed and there was a pressure to execute the experiments in batches with a limited time. In the fifth why was there pressure to execute the experiments in the limited time? The curriculum was designed to maximize the hands-on experience but it did not allocate adequate time for comprehensive safety training. The root cause, the curriculum design emphasized on hands-on experience but did not allocate sufficient time for a thorough safety training, leading to an insufficient understanding of safety procedures among the students. In consideration of action plan, revise the curriculum. Modify the curriculum to allocate more time specifically for safety training, ensuring that it is thorough and not rushed. Integrate the safety procedure into the course content, reinforcing them throughout the semester rather than only during the initial training. Enhances safety training. Develop and detailed safety training modules, including both the theoretical and practical components. Introduce regular safety drills and assessments to ensure the students retain and correctly apply the safety knowledge. Instructor training. Provide an additional training for the instructors and lab assistants to emphasize the importance of the safety and to ensure they can effectively teach and enforce the safety protocols. Continuous monitoring and feedback. Implement a system for a continuous monitoring of a safety practices in the lab with the regular feedback sessions where the students can discuss the safety concerns or near misses incidents. Establish a reporting mechanism for accidents or unsafe practices, encouraging the students to report any issues without a fear of failure. Safety audits. Conduct a periodic safety audits of lab facilities and equipment to identify potential hazards and address them proactively. The probable outcomes will be immediate improvements. Following the implementation of these changes, the number of accidents in the lab decreased significantly. Students reported the feeling more confident in their understanding of the safety procedures. The department observed a cultural shift towards the prioritizing the safety. This has not only improved the immediate lab environment but also instilled a mindset of safety consciousness in students that they carried out into their professional careers. Scalability. The success of this initiative lead to its adoption across the other engineering departments where the similar safety challenges were identified. The university also shared this case study with the other institutions, contributing a broader improvements in the engineering education safety standards. As a part of a reflection, this case study illustrates the effectiveness of 5 whys analysis in identifying and addressing the root causes of the problem in an educational setting. By understanding the deeper issues behind the lab accidents, the department is able to make meaningful changes that improves the student safety and learning outcomes. This approach highlights the importance of aligning the curriculum design with a practical consideration like safety, protecting student well-being while achieving their educational objectives. The 5 whys analysis is a powerful and cost-effective tool for identifying the root causes of the problem. By repeatedly asking why, teams can move beyond the symptoms to uncover the underlying issues and implement the effective corrective actions. However, the quality of analysis depends on the knowledge and the experience of the individuals involved. Sometimes the root cause may not be identified within the 5 iterations. While it has limitations, its simplicity and focus on the root causes make it a valuable addition to any problem-solving toolkit. Identifying the root cause is not enough. Corrective actions must be implemented and monitored. I hope that you will be using an 5 why analysis for identifying the root cause of one of your academic difficulties. Thank you for watching. Happy teaching.